Lynn, let it begin. It ain't no sin. We're just here to win. We ain't gonna grin. We're in the bin. We ain't gonna. Damn, I ran out of N-words. Welcome everybody to episode 28 of the Swift and SwiftUI Learnalong. This is the stream where your host with the most does not boast. I just would like to make a toast to all the great people out there watching and have that insatiable desire to learn. That is why we're here. But also started a company. I want to learn Swift so I can build an iOS app. I have experience writing a lot of SQL, about a decade in the service industry, working for an ERP reseller and writing some Golang applications. But this is the first proper run through for a general purpose programming language. And the more and more I get into this and the more and more that we do this, I got to tell you guys, because I truly am, I'm not touching this off stream. So everything is on stream. All the learning has been on stream. I'll say the past week has been, I don't want to say a revelation, but I'm getting that high again. You know what I'm saying, brother? Not playing, but I'm getting that learner's high again. It's a lot of fun. I am feeling not even just good about my choice in terms of the programming language, but great. Feeling great. So we're going to keep it pushing, keep it going. And if you're new here, this is just the beginning. So we're going through Swift. We're using the Big Nerd Ranch guide. I am reading it to you effectively. So this is what I like to call fly on the wall type learning. I will not be interacting with you directly. Sorry, brother, sister. But I do hope that there's some... What am I saying? I know there's value here because I'm going to be talking through it and just kind of spilling all of it. It's cathartic for me. I'm actually actively learning while I'm doing this, and you guys will be able to pull from whatever I have to give and also learn at the same time. Okay? Now after this, we're going to roll into SwiftUI specifically, so it won't be a big nerd thing. It'll just be I actually don't remember. I don't know what company, but I purchased a different course that's focusing in on SwiftUI, which I'm intrigued about it because the way that it was sold, it was just good marketing, honestly. I don't know. We won't know if it's good until we get in there, right? But what was interesting about it and what stuck out to me is the marketing really, what's the word? Resonated with me because the pitch was effectively that the problem with educational material in general is it becomes stagnant and dated so quickly. Not all the, like, there are some exceptions out there. Long-standing technologies like, you know, like the old-ass C book that everyone talks about, that everyone's probably read some portion of. If I showed you the cover, you'd probably see it. It's in my library. Matter of fact, I will show you because if you're curious about C, if you ever want to learn C, this is the book. And actually, oh, you know what? Well, I'll show you at the end of the stream because actually I saved that bookmark somewhere. I'm just not sure where, but I think it's on my board mix. But yeah, you know the dude that did his name's Dr. something. I'm terrible with names. But he's the guy that has like the most popular free Python course on YouTube. And he's like wearing shades. Looks like a biker dude, but he's really like a super smart programmer dude. But yeah, that guy ended up basically rewriting that C book that I'm referring to. Well, I say rewriting. He put it into an HTML document and put it online for free. And, you know, and he talked about it on, I remember this guy's name for some reason, David Bumble. He does he's also on YouTube. So he had this guy on his YouTube channel doing an interview. But David Bumble, I think is his name. He does a lot of like cybersecurity stuff back when I thought I actually wanted to learn, like do a deep dive into cybersecurity and Kali Linux. What a how naive I was. But yeah, anyway, we'll get there. But the point is, we're going to be learning that. I got way off on a tangent there. I'm not sure how I got there, but so we're going to do SwiftUI after this. Then we'll do some schema planning. So we'll design the schema for the application. I'll tell you guys all about that, more about that. I've talked about it enough yesterday, so I will refrain today. And then after that, we're going to come back to the book learning to then cover another big Nerd Ranch guide on iOS programming and, well, iOS and macOS, really. My presumption is that we will cover the full gambit of working with each of Apple's particular frameworks and APIs. So that would be more, deep platform learning. So that's the lay of the land. So if you're into that, if you dig that, or if you just dig me, brother, sister, then go ahead and drop a whatever. They need to just come up with one term, seriously. A like, a sub, a hug, a nub. Like, it's too much. It's just too much, brother. I'm streaming to 3 places right now. I don't even know. Anyway, it's these are all good problems to have. Better than the stick in the eye. So yesterday, let's get into this. Yesterday was bittersweet, and I think today will be a little bit more of that, at least the first half, because we've been going through and learning about initializers, which is fine, but a big portion of yesterday was relative to classes, and I have no intention of using those, simply because with them it brings inheritance, and I don't want to use that. So, but we're learning it nonetheless, because like I said yesterday, we're probably going to run into classes quite a bit in the GUI space, in the SwiftUI space, so we should understand it. So we will persevere. So then, let's see, where did we leave off? I don't think we started on the D in it. Yeah, I don't think we did. Okay, so we're going to start here after I get some water. Yeah, okay, now that I read the code, I recall somewhat. So we main Swift, I thought we added it. Maybe it was oh yeah, it was zombie, right? D in it, there we go. Yeah, so we ran this ran, just confirm, yeah. You can't really see it, I don't think. How does it look on the, yeah, it's too small. In the bottom right hand corner in the console, these are just all the outputs we're sending to the console. And second to last, zombie Fred is no longer with us, which is our D in it. So far so good. All right. Open main.swift. To exercise the zombie's D init method, you are going to set Fred the zombie to be nil at the end of the file. Doing so will trigger the process of removing this instance from memory. There are some other changes you will need. Wait, print zombie. Oh, okay. So you would, I want to make sure I didn't miss anything prior to this. It doesn't look like it in terms of setting it to nil. So actually, let me just reread this deinitialization. Deinitialization is part of the process of removing instances of a class from memory when they are no longer needed. Conceptually, it is the opposite of initialization. Deinitialization is limited to reference types. It is not available for value types. And why is that, brother? I'm actually pretty curious why. In Swift, why are D-inits limited to reference types only? In Swift, deinitializers denoted by dinit keyword are used to perform cleanup tasks before a class instance is deallocated. The reason why dinit is limited to reference types classes only are not available. The reason why dinit is limited to reference types only and not available for value types, structs, and enums lies in the fundamental difference between these two types. Reference types. When you create an instance of a class, it is allocated on the heap, and multiple references can point to the same instance on the heap versus the stack, brother, right? Yeah. When there are no more references to this instance, it is deallocated, and that is when the dinit method is called to clean up any resources associated with that instance. Value types, structs, and enums. When you create an instance of a struct or enum, it is allocated either on the stack or copied. It is allocated either on the stack or copied. Oh, okay. So you can't, I guess since it might be in the stack, you can't just allow the dev to say whenever, suddenly it's nil, because it might not be next man up, and then you can't just pluck it from wherever. From my very brief tiny readings of the stack. But okay, so when assign a pass. Therefore, there's no concept of deallocation for value types like there is for reference types. Since there's no deallocation, there is no need for a deinitializer. In summary, dinit is used to clean up before deallocation, and because value types do not have a similar deallocation process as reference types, they do not have deinitializers. Yeah, but okay, I want it to tell me just a little bit more. But why though? But why? Can you expound on why? Different life cycles, yeah, makes sense. Yep. I guess it doesn't matter. I mean, it's not like as an app developer you're going to be, at least not in Swift, writing a code that's going to control it to that degree, but you never know, brother. You might call into C to do some stuff and reclaim it when the value is no longer in scope. Oh, okay. When you create an instance of a value type, a unique copy is made. This means every variable has its own distinct copy of the data, and changes to one copy do not affect any other. The system manages the memory for value types, automatically allocating it on the stack and reclaiming it when the value is no longer in scope. Okay, that does make sense. Okay. All right, so we don't necessarily need to beat that dead horse, beat its ass already. All right, so open main.swift. To exercise the zombie's dinit method, you're going to set for the... Oh, we did that. There are some... Oh, we did this stuff. Okay. You created new strings. Build around the program now. Oh, yeah, this is where we were. Not sure how I got back to 413. Okay, failable initializers. Sometimes it is useful to define a type whose initialization can fail at runtime. Sometimes it's useful to define a type whose initialization can fail at runtime. For example, imagine defining a struct to model a combination lock, such as what someone might put on their luggage. You would want to ensure that every new instance has initialized with a 4-digit integer combination 0000 through 9999 as its argument. Checking that the passed in combination is valid must happen when the program is running. What should the initializer do if the combination is invalid? There's that motion over there, buddy. Checking when the program is running. What should the initializer do if the combination is invalid? One solution is to return nil from the initialization process. In these cases, you need a way to report to the caller that you were not able to initialize the instance. You use failable initializers to handle these scenarios. God, I hate this fucking app. Alright, so then here. Okay. A failable town initializer. A failable town oh wait, why did I read that twice? Failable initializers return an optional instance of the type. To indicate that an initializer is failable. Failable initializers return an optional instance of the type. To indicate that. Oh, okay. Makes sense. You can also use an exclamation point after init to create a failable initializer that returns an implicitly unwrapped optional. Returning an implicitly unwrapped optional allows you to avoid optional unwrapping syntax, but remember that Swift provides that syntax to make optionals safe to use. Yeah. I think it's quite nice. So, you know, I don't... So they're referring to this right here. The optional chaining. So since Fred the Zombie... Wait. Oh, right, yeah. So since zombie is of type optional zombie, so it could be nil, then you have to use the chaining like this. But that's what they're referring to. Now, if you did the implicit unwrap, so zombie exclamation point instead, then we can just write it like Fred the Zombie equals terrorized town type thing. Basically the way we had it written before they showed us. But we don't. But I don't think that's too bad, actually. So, like this right here. Fred the Zombie, question mark. I don't know. Doesn't bother me one bit, so I think I'll just roll with that. All the implicit stuff, more than anything, the things that trigger me when we read through this book here, anything, all the implicit, it's always has something to do with that. Just stop doing it, brother. But there are some nice things about it. So return an implicitly unwrapped optional allows you to avoid optional wrapping syntax, but we read that. So be cautious about returning implicitly unwrapped optionals. If an instance of town is being created with a population of 0, then initialization should fail. You cannot have a town without a population. Open main Swift and change the initialization of my town to have a value of 0 for its population parameter. Okay, so instead of 10,000, brother, you want just 0. Stoplight 6. Okay. This does not cause an error yet. Switch to town Swift to give the town struct a failable initializer. Okay. Oops. Wait, to give the town struct available initializer. Town has 2 initializers. Remember that you delegated from the init population stoplights initializer to the init region population. Right, yeah, we do remember that. I remember that. Initializer in this type. So they're referring to this guy here. So we learned about the whole primary / designated initializer. And so in this case, a designated initializer is one that fulfills the requirement of giving all properties values. And so since this one already existed, if we wanted to have a alternative initializer, you can write it like so. So in this way, you would be able to make your caller only provide population and stoplights. Whereas if you initialize with this one, you'd have to give it a region, population, and number of stoplights. So if you initialize with this one, then in the body, it just refers to self init, which self puts it back in scope which is on the level of the init. So it sees this, and then it matches the signature. So region, population, stoplights, and that's the same thing we got up here. So you're still providing everything that the type itself, in this case the struct town, needs. You dig? Okay. So that's what that was. Oh, we finally got there. I see the word guard. We finally got there. They mentioned it like 8 chapters ago. Okay, so for now, just make the init region population failable. Okay, fine. So init region control, no. Is it 0? Yeah, 0. Okay. To go to the beginning of the line and init. I'll get rid of all this. Okay. Guard population. Oh, it's a new block. Okay, I'm a little bit blind. All right. So I need to learn how to. How can I get to that prior word, next word? B. Oh, that's easier. Cool. Okay. Here, really? Open up new scope. Wow. Guard population greater than 0. Else. Wait, what does this match into? Closure expression is used to God damn it, I fucked up these fucking parentheses, dude. Oh my gosh. All right, just go back. Go back. There's a hard rule here. We don't copy and paste unless I get lazy, but I'm really trying not to. I think there's something to the muscle memory aspect of it and just looking at it. So I'm just forcing myself to do it. But yeah, if you're wondering why I'm struggling in this manner, that's why. Okay, brother. Feel free to yell at your phone. So, all right, I'm back where I started. Yeah. Okay, so let me just. I am just adding. Oh, inside the man. Okay, that's what I should do. All right, brother, I'll tell you. All right, now if it's greater than 0. Okay, so if it's very literal in the way that it's being used, so we're saying guard, like create this guard, and the guard is, or a condition that the population needs to be greater than 0, otherwise return nil. That's cool. See, for every kind of annoyance that we've come across, Swift gives you like a really sensible, more importantly, like a very pragmatic, useful piece of syntax. I like this. A non-failable initializer cannot delegate to a failable initializer. Propagate. I presume that's what they'll have us do. Okay. You now use the failable initializer syntax in init. After this declaration, you check whether the given value for population is greater than 0. If it is not, then you return nil if the initializer fails. In the context of failable initializers, fail means that the initializer will create an optional instance of the town type with a value of nil. In the context of fail, that's a highlight for sure, brother. Okay, hold on. Yeah. Okay, you now use the failable initializer. Wait, we got there. Okay, so if it is not in the context of failable initializers, to fail means that the initializer will create an optional instance of the town type the whole thing? I don't understand that. This is good. It is preferable to have an instance set to nil rather than an instance with bad data in its properties. I mean, okay. I mean, that is true. I agree with that, but I don't know. I thought that was not possible. We just spent the whole last 2 days talking about how the requirement is that everything has a value. Well, I guess like with most things, it's like, hey, this is true until it's not. Kind of a thing, I guess. Doesn't matter. Nonetheless, we learn it. Okay, so then you can do that. Now is the whole type, the whole struct means that the initializer will create an optional instance of the town type. Yeah, so it must be the value of nil. This is good. It's preferable to have an instance set to nil rather than an instance with bad data. Yeah. Okay, at this point you should notice a few errors in your program. Build your program. If you do not, you can build without using product build. Wait, what? Build your program. If you do not, you can build without running using product build or command B. Okay. Is that, oh, so B, does R not run a build? Yeah, it does. Builds and runs. Okay. So, you know, the thing that maybe I don't, this is a quick aside, but I'm just curious if I keep comparing to Go, but you know, like in Go, just like the way we just ran Command R, in Go, you would just go to the project directory and do a go run main Go would be the equivalent of the Command R. Which it's nice because this has its own dedicated IDE, right? But surely there's a CLI that I can do that with too, I hope. I'd be shocked if that's not true, but can I run a command from the terminal? It's the equivalent of go run main. Okay, good. Oh. Okay. Well, brother, let me shut up. Good job, Swift. Awesome. All right, so then I guess my other question is, where the hell is the terminal on this thing? Surely it has one. It has a console. Navigate. There. There's no way it doesn't have one. It's gotta have one. Wait, what? That's what that is? I thought it was a broken variable. Yeah, there's a, what do you mean? This is not terminal. Local, all. Lies. What, dude? Oh, I didn't know you do that. Well, whatever. I don't care to look for it, but I thought it would be more obvious where it is. What does this do? Inline, minimap, code coverage. No, I don't want to wrap lines. Alright, I give up. Okay, so where were we? The initializer in it. Fix this problem. Oh, right, the errors. Okay. So value of optional type town must be unwrapped. Okay, so we should have expected a lot of these because we changed the type all the way down the way. Cannot use mutating member on a mutable value. My town is immutable. Why did that happen? Optional must be unwrapped to refer. Okay, so all the other ones I think were pretty expected, all related to making it an optional. So making the town initializer available, town initializer, fix a problem. It'll take a moment to consider. The initializer population stoplights here, 29, currently delegates to a failable initializer, which is the one we just changed because self init. This suggests that init population stoplights may get nil back from the designated initializer. Okay. Receiving nil back from the designated initializer would be unexpected because init is not failable itself. Okay. Oh, I did. Yeah, okay, that's what it told me to fix earlier. All right, so we did that part. Now try to run the program. You'll see that there's still a number of errors that you have to fix. You can find these errors in main Swift. Hot dog. And get rid of that too. Blah. Where was my spot? Oh, the line mytown.print description, so 12, has an error that reads value of optional type town must be unwrapped to refer to member print description of wrapped base type town. Read that 3 times fast. Value of optional type town must be unwrapped to refer to member print description of wrapped base type town. Unwrap to refer to member. Oh yeah. Easy money. Just basically put that everywhere. Look at that. Why would you want to do implicit? And you can just do that. I really like this. I think they did awesome with the switch statements, the optionals. There was something, really the functions. I mean, I like the functions too, but that's pretty standard. I mean, the way that they do those work pretty much the same across most languages. Cannot use mutating member on. Well, except we did see, so we saw, yeah, I say that, but we haven't touched protocols yet for one. And also, what did we see? Go did not have this, but other languages might. So I'm not saying this is a Swift specific thing, but what might make it even more, I'll say, ergonomic / powerful and potentially more complex. We saw there was support for multiple, what did they call it? We read it yesterday on what's coming with, or no, this was already there. They added it in 5.9, where you can have multiple, what's the term? Basically, you can have multiple arguments in a function, or no. You can have multiple parameters for a single function that are, I can't fucking remember the term. It's gonna kill me. But basically, you don't know how many arguments there might be. I can't think of it. I got nothing. We'll go look before the stream is over, because that's gonna bug me. But matter of fact, boy, that coffee is running right through me, brother. We're going to take a brief intermission. So if you need to get up, go get some water. Now is the time. Why don't we meet back here? Meet back here at, how long do I think? You know, it's always tough trying to gauge your, how much time you need. You understand? So why don't we just call it 15 minutes? If I'm back early, I'm early. Okay, so 12:05. Yeah. Let's be aggressive. 12 CST. All right, be right back. Dog hot diggity dog. Yeah, right on time, brother. Hold on, I need my blanket. Don't worry, we here. Just grabbing a quick little drink. All right. This place is so confusing. It's hot, it's cold, it's hot, it's cold. Maybe if I just... I wish humans could buy new skins like from the shop. I wish it was that easy. Then I could have like a whale build that I could run, you know? With lots of blubber. Then I wouldn't need to worry about no blanket, brother. Blubber is the best insulator. All right, so if we get... hold on, wait a minute. All right, there we go. Okay. Teach me something. All right. We did the optional unwrap on the initializer. Cannot use mutating member of on immutable values. My town is my town question mark. Expression implicitly coerced from town.size to any. They didn't mention that one. Print my town size. I guess this is kind of the downside of optionals because you have to with string interpolation, but I guess it's not horrendous. It's just verbose, but let's see. Print string. Oh, that's where it is. Okay, so it is there. I just got to add an order. So town size and then print string describing Isn't that interesting? I should probably I already know that I'm gonna have to get back to that, so let's make you red. And this will be for our board, so I'll have to get all these together, but example of string interpolation. Example string interpolation when using handling optionals. That's good enough. I'll catch the meaning. So then last one. What do we got? Value optional type. Town must be unwrapped to refer. Yeah. Force unwrap. No. Chain. Yes. No, we gotta do this again. String. Describing. What was the other one we just, yeah, there it is, by town. And then, can't see what, pow. No. Okay, damn it. I was trying to get fancy. Okay, what do I need to fix then? My town, I got that, town size, fix the print, then my town change population. Value of optional type. I wonder why I don't have to print size. Well, they'll probably tell us, yeah. I'm not sure why those have to be handled differently. Meaning we don't have to do this thing. Okay, so then where else did you change? No, I got that one. Change population by 1 million. Print size, my town string, got that one. Town size, population. Oh no, they did change it. Okay. String. Describing my town. Oh, I had something out of place earlier. Okay. All right then. Cheerio then. Note that the last print statement should be all one line of code. Yeah, 16. Note that the last print statement should be just one line of code. As you can see, representing nil in Swift tends to have a fairly extensive impact on your code. Yes, these changes can add complexity and more code to your project. Both increase the chances of making a troublesome mistake. We recommend that you minimize your use of optionals to those cases in which you absolutely need them. Building, come on, brother. We did it. It ran. What is that? Yeah, I don't think produces a debug description for an optional value. Provide a default value to avoid this warning. What do you mean? I did do that though. What did it just change? Oh. But we did not do that here. We did. No, we did. Yeah, no, we did do that. Okay, so I shouldn't have done that. Go back. B. That's a little faster. Alright, so we're just doing same thing. Describing my town size. Or what was it? My town size. There we are. Okay. Victim pool optionally. Zombie has a bad knee. Fred is no longer with us. Okay. Good. As you can see, we recommend, build and run. Alright, there we are. Aside from your print statements printing nil now, you're also... Oh, you're right. You are also missing a print statement in your output. Which one? Victim pool. Print. The description? No, it's there. Yeah, I don't know which one. Okay. Because my town is nil, the optionally chained call to print description does not happen at all. Oh, I thought that's what the size and population was. My town print description. Oh, that's from the type. So what is messing with my... What's the deal? Come on, man. You're gonna be here, you're gonna work. Alright, come on. Alright, so this, there, and the time variable, next order. Yeah, so in town, we... had a method in here. Where'd it go? There it is. Okay, so that's what's not happening. Because it's nil. So there's the method, and then on the initializer, var print, or no, it is in main. It's in one of these. Oh, right, yeah, right there. So that's what's saying if my town is nil, then it's not going to run. Print description. Okay, it's time to say farewell to Monster Town. For the next several chapters, you will move back to Swift Playgrounds to focus on some specific language features. If you are itching to work on more projects, fear not, there are more projects to come. Yeah, I wonder why it had me create that copy that one time. Okay, so we're going back to Playgrounds. Initialization going forward. How am I going to remember all this? You won't. We hear you. Initialization in Swift is a very defined process with a lot of rules. Rules that even longtime Swift developers frequently forget. You know, it's kind of cool to think about this, because when you think about, like, C came out what? C is like 50 years old. But a lot of the languages, even, you know, Python came out in the 90s, you know? So in a sense, it's kind of a big deal. Because with Apple, you know, because yesterday we read about the adoption of Swift, you know, really taking off and replacing Objective-C in a big way with respect to surveys and what developers are doing and what they're using to build new apps and whatnot. And so if you think about it, Swift came out in 2014. Relatively speaking, you know, compared to 50 years ago or 1990 or even the year 2000. Like most of what we use came out in the 70s and 80s, like C, C++, you know, like it's crazy to think. So with Apple being so prominent, like it's totally feasible. It's not even a question to say, you know, could a developer strictly only work in the Apple domain, or in Apple's ecosystem, I should say, and still have a, you know, vibrant, promising, tons of accolades, successful career? Like, could you do that? And because Apple is so big, popular, there's so many customers, potential customers, that you totally could, which is a big deal, because I'm just pointing out the fact that, I mean, I'm no spring chicken, but you know, there was always kind of a, like, it's just rare that you have a chance to really start over like that. Like 10 years is a drop in the bucket if you're talking about comparatively to other programming languages where you might stack up in terms of expertise and like being able to know the full history of something. And when that something is your primary tool that you use to create all the things, most of the things in some degree, to me it's a powerful opportunity to be able to do that. Yeah, so I mean, I'm drinking my own Kool-Aid here, but I'm just saying, I'm feeling really good about this choice. I'm just saying. That's all I'm saying. The more and more I spend time with it, you know what I mean? I ponder these things quite often, but I'm like, yeah, this is good. We want it to have, like, more is more, not less is more. More is more, brother. Stop with the underhanded cross semantics. If this, then that. No, if this, then this. This is this, and that is that. That's why they're called this and that. But I digress. Okay, how am I going to remember all this? We hear you. Initialization in Swift is a very defined process with a lot of rules. Rather than memorizing all the rules of initialization, it is useful to think of Swift initialization in terms of value types and classes. Yeah, I agree. And that's how it was presented, so I believe that they believe that as well. Ah, man. I think I'm going to have to get my neck reinstalled. Just uninstall, reinstall, see if it fixes it. So for value types, such as structs, initialization is principally responsible for ensuring all the instances stored properties have been initialized and given appropriate values. That statement is true for classes as well, but class initialization is a bit more complicated due to classes' inheritance relationships, right? It can be thought of as unfolding in two sequential phases. In the first phase, a class's designated initializer is eventually called either directly or by delegation from a convenience initializer. At this point, all the properties declared on the class are initialized. Well, we're just going to save that. They're summarizing what we've really beat this dead horse. So, you know what I wanted to try though? This is, let me copy that there, brother. Let's see what this thing can do. Please visualize the following excerpt on Swift using a diagram. I'm telling you now, you probably have, I'm going to guess like a year or two before people really get, you know, because like people that are tech forward are, I mean, you'd be surprised, but it's hard for you to imagine because you're here coming across content like this. So clearly you're in this space, in this domain. Other people, not so much. You know, AI is like a, you know, it's like crypto, but they wouldn't touch either one. They don't, it sounds too complicated, you know, that kind of a thing. But I'm only saying that we have a year or two before I think it really starts to bleed into all the like end user products heavily. And I mean, it's kind of already there, like in Office 365, but it needs to get better. It needs to be faster. It needs to be not so expensive, and it needs to be even simpler to use, I would say. And companies still need to kind of, you know, like, we accept this, because there's a lot of issues. It causes a lot of network traffic too, which is a problem. That can be a problem if, you know, you're on, like, a lot of companies are remote. If you're on a VPN, if everyone's using fucking AI to throw up all this, you know, that's a problem. It's gonna cause problems. But that being said, I'm just saying, for any, not for code. I mean, I'm not suggesting that you use it to write code, because it's just not good enough. I know firsthand that this is true. It can help you, but it's not good enough to, it's just not. But it can help you get started and whatnot. But in terms of like ingesting and making summaries, I mean, think about how many times you sat through meetings. I mean, I'm in client meetings quite often. Imagine just being able to record a meeting on Teams, right? Transcribe it. Even if it's an hour-long meeting, if you think about it this way, it's crazy. An hour-long meeting, transcription, you could take all that. And for $20 a month, and if you're paying for the current version of Gemini, I don't know if GPT has a big enough context window, but I'm just saying, let's assume it's a little too much for what ChatGPT affords, but we know that Gemini has a 2 million token context window. You can just go throw it in there. Hey, give me a summary. In a matter of minutes, you get this nice little summary, spot check it, fire it back out to the team. Can you imagine? People love that shit. Everyone involved, the stakeholders that would see that. In less than 30 minutes, you got this beautifully laid out, bulleted summarization. Or maybe you already do that now, but now you can just do it way quicker. So it's for that kind of stuff, I think it is great. But yeah, so this thingamajig, I think did I thought it was command. Oh, there we go. Oh no, wait. I'm almost certain they added this, but we'll see. Triptych. Oh, brother, I thought you... God damn it. Nah, I was not paying attention. That's not really a diagram, brother, but... Or maybe it is. General properties. Oh, wait, yeah, that's actually kind of nice. Cool, I will save that. Thanks, ChatGPT. Thanks, brother. Alright, so that is... initializations or Swift and a tag Swift big nerd. All right, now then, brother, back to it. Fully reverse right now. The goal of this very definite initialization process to guarantee the successful. Oh yeah, okay. Silver, gold. More curious. Initializer parameters. Let's read through this. External parameter names distinguish between the parameter names available to callers and the local parameter names used in a function's implementation. External parameters names distinguish between the parameter names available to callers and the local parameter names used. Oh, yeah. Okay, so let's go take a look at one. I know we had one because we talked through this earlier. Oh, here's an example. So on line 58 here. So this is the function signature. And these are the arguments between the parentheses, or the parameters in the parentheses. The by is the external parameter name. So this is just how you represent an external parameter name. So you write whatever you want it to be named externally. So the caller would use by, but internally, the parameter is named amount. And this is the actual parameter name, or the internal parameter name, which is why inside the body of the function, the increment operator is referencing the internal parameter name and not the external. But if we go to main Swift, where we use this method here, the change population by, what is this doing? What is under there that's like fucking me up, brother? It's getting my goddamn nerves. Hold on one second. It just dawned on me that it might be a good idea to use the trackpad. I'm working on this stupid ass kitchen table currently, just because it's a lot more wide, so I could fit my Mac, my Windows machine, my monitor, my iPad. Bit of greed, but you know, whatever, brother. So what I need to do is disconnect this here. Where is it? Oh. Forget. And then turn that bad boy right there. See, it's like doing the whole jitter thing, and it's really upsetting. Connect. The Mac can no longer connect. Big. Come on, dude. come on, man. Shit. Still not. Oh, I wonder if it's dead. It might be dead. Ain't nothing but a hooch mama, hooch mama. Oh shit, it was dead. Look at that, brother. Through the power of deduction, we have overcome the challenge. Indeed. Okay, so turn that off, brother. For some reason, some of the... whatever, it doesn't matter. I don't even want to talk about it. Okay, so where were we? For the more curious... oh yeah, we were going over what this look like. So the by and the amount. So that's the internal parameter name, and the by, by. But it can be anything. It can literally be anything. And so if we go to main Swift and look at yak, if we can scroll setting. I'm not sure why where is it? Scroll and zoom, natural scrolling. Ah, it's much better, dude. Not sure how it got turned off anyway. Okay. External parameter names distinguish between the parameter names available. Oh yeah, we read that. Follow different naming conventions. Because initializers follow different naming conventions than other functions, initializers are always init, which we learned. But they are technically still a function. The parameters names and types help determine which initializer should be called, i.e., its signature or its arity. That was the word, arity. Ah, see? Damn. Okay. So Swift provides external parameters for all initializer parameters by default. Initializers are always init. The parameters names and types help to... yeah, but so Swift provides external parameter names for all initializer parameters by default. Show me. I don't remember that. Yeah. You can also provide your own external parameter names as needed. For example, imagine a weight record in pounds struct that should be initialized with kilogram struct weight. Let weight double init. What are you saying? That just by default it would, like, we'll just change the, just get rid of that. And then on main, where do we? So this would be amount now. Okay, so let's see if it'll run. It will not, but where is this? Oh, in zombie. Oh, yeah. But that's all it's saying, so I mean that makes sense. So since we didn't in the town file, so this change population is a method on the town type, and since we removed by and we only give it the internal parameter name, they're saying Swift automatically makes this the external parameter name too. So makes sense, I think. Makes sense well enough. By actually, we're about done with this, so I guess it doesn't really matter. Go back, dude. There we go. Okay. All right, good. We're set. So that's all that's saying. So that makes sense. I understand that. We understand we can provide our own, just like we can with the function. And then so the underbar is just the wildcard. So we could even have we could do it like this. Then the caller wouldn't need to name it at all. Okay. Yeah, they do a good job of looping you back to where you learned something first. It's appreciated, brother. All right, the wildcard is used like let weight equal. Yeah. Okay. Oh boy. Value versus reference types. Oh no, wait, we covered both of those already to some extent. This chapter reviews and builds on the lessons you've been learning about value types and reference types. You explore the difference between the two by comparing their different behaviors in a variety of scenarios. At the end of this chapter, you should have a good understanding of when to use a value type or a reference type. The answer is never use a reference type, because reference type is equal to classes and we don't want to use inheritance and we don't need to. Therefore, why would we make our life harder than it has to be? That's my answer. And it's the only one that matters. Kidding. But I'm not kidding. And we need to go to playgrounds now. Value semantics. Oh boy. Create a new macOS playground called value versus refs. Okay. File. Oh, I keep getting those mixed up. I keep thinking, so it's still Xcode, but it's Playgrounds is, I mean, it runs on the Mac now, but it was designed to be an iPad iOS app. But Playgrounds, like as a thing, like not the app, but describing the environment, the sandbox environment, is available in both and is the same underlying thingamajig. File. I'm using the big glass trackpad. Feels very foreign to me. Playground. All right, we got there. So macOS blank, and you want me to call it value versus refs. Value versus refs. Learning, create. Okay. Oops. Nope. All right, what do you want me to do now, brother? Escape DD. You have seen this code many times before. You have a mutable instance of type string set to the value hello playground. Make a new string by giving the value of stir to another instance. Okay. Bar playground greeting equals stir. Oh wait, yeah, okay. That's not bar stir. Okay. Playground greeting has the same value as stir. They both hold the string hello playground, which can verify in the results sidebar. So this one was different. Command R does not run here. It's oh, Command Shift Enter. Surprised how long it takes to... Oh no, it did. Never mind. I keep thinking that spinning wheel means it's working on something, but that's... Or it might be, but you get your outputs ahead of that and it just keeps going, so I don't know. Okay, hello playground. Yep, so we see that. But what happens when you change the value of playground greeting? Will it also change the value of str? Let's think about this. It's a variable, it's a string. It's in memory, so we run it. It gets created. The answer is no. Not if we don't rerun. Or not if we don't update. Playground greeting. Yeah. Because we know that because we haven't seen them yet, but we learned about observers, which if we wanted to set up some kind of reactive thing where it would automatically update, that's what we would have to do. Otherwise, these are two separate things, two separate points in time, but when line 4 runs, it gets the value of str at that point in time, and then it's just that until something else, it's its own instance at that point, until something else affects it. So remember, if you change, will it also change the value of stir? Change playground greeting to find out. Okay, go back. Playground greeting, increment operator plus equals excla, how are you today? Is that it? Yeah, exclamation point, how are you today? And then str. Command Shift Enter. Hot dog. We are programmers. As you can see, even though playground greetings value has been updated, str's value has not changed. Why not? The answer has to do with value semantics. To better understand value semantics, option click on the playground greeting. You should see the pop-up shown in figure 18.1. Yeah, I mean, we understand this. So what are you telling me, brother? Yep. Yep. Scroll down to the section called modifying and comparing strings. Yeah. I mean, I'm not going to... We did an aside on this on when we first covered the concept. Yeah, so I'm not going to linger on that, but I get it. Now these would, because it's just a reference. So if you update something in a class property and something else was establishing its value based on that, it would update, because there's only... that thing only exists in one place in memory, and everywhere else it's being used is just a reference to that memory location. So it's the opposite. Reference semantics. But I'm still reading just to be sure. But yeah, just very quickly, this is... Yeah. Yeah. All right, constant value and reference types. Hot dog. Making the company. Value and reference types behave differently when they are constants. Value and reference types behave differently when they are constants. To model a list of employees who work together, define a new struct called company. Oh, it still wanted me to write all that. Equal. Damn it. Let me go back and just copy that code, even though we're not going to read through it. Or sorry, not copy. That's heresy. Type out. Class as employee var id int equal. You know, you can... What's funny is you can use... You know, Swift supports Unicode, so you can use emojis in your code. Well, not this one. I mean, not here, but you could... We'll do equal snowman, brother. Or dookie. What? Oh, you gotta do it like this? Is evidenced by where did I first see this? Command shift enter. Oh, on Fireship's video. Well, then get the heck out. I just want to see it happen, and then we can get back to it. Command shift enter. Nice. I love that. All right, so then class employee var, what did you, int. Okay, so we're setting up class type called employee, has a single property, a variable, a mutable variable called ID of type integer, and has a default value of 0. The class employee is small. It supplies a single stored property to hold on to the employee's ID number. Make a new instance of this class. Let Anika employee. You now have a new instance of employee with the ID 0. Some other employees only know Anika as the boss. Make a new constant called the boss and assign Anika to it. Let the boss Anika. Okay. Let the boss. Yeah. Uh-oh. Anika's employee ID is 16.0. At this point, you have two constants, but they both point to the same instance of the employee class. Update Anika's. Why does that sound so strange? Anika's. I knew an Anuka. Anika. I think that's better. Update Anika's ID to see this. Okay. Oops. Update it in what way, brother? What are you talking about? Slacker. Oh, duh. Alright. Alright. Anika 16. Anika ID. Yeah, this was one of the... Okay, yeah. Now I'm accessing it like that. I like that a lot. .id. Command Shift. Enter. Did it? Did it? Change this back here. Tab. Here. This. There. There. Not control, damn it. Which one was it? Okay. All right, so boss ID. The code in listing 18.6 changes Annika's ID and leaves the boss's ID alone. But the ID property for both of them has changed to 16, as shown in the results sidebar. Yeah, because we're getting it from the same place. The code employee created an instance of the employee class. When you assign an instance of a class to a constant or variable, as you did with Annika, that constant or variable gets a reference to the instance. Yeah. Yeah, I mean, to me, I don't know, maybe it's because just in a past life, working with other things, but this is, I mean, this is obvious to me. You just have to look at what you're pointing to. It's like when we create the first instance, Annika equals the class itself. But then the boss equals Annika. And so you just got to look at the order of operations. So in this case, if we're going top down, so here's the class, nothing exists yet, right? Other than the class itself. Well, even that's not true because it wouldn't be, yeah. So this really starts everything. So we just define it first and then Annika is the first instance of employee. So Annika, at this point, we're only on 14 yet, 15 hasn't occurred. So at this point, Annika gets ID 0. Okay. And so the next thing that happens is now the boss is equal to the state of Annika. So still 0. They would both have ID 0. But then we change Annika's ID to 16. The instance Annika.id to 16. And the boss is equal to Annika. Therefore, it gets the same change because it's pointing to the same place. You dig? Cool. I think y'all get that. To me, it's pretty straightforward, but I mean, no doubt you'll probably still run into bugs like that because as things grow, like you can only imagine this is not very much code at all, but then when you're working with multiple files and all that, I'm sure we'll run into it often, but as long as you understand the concept, ain't nothing to it but to debug and do it. So could code employee create instance, assign instance. Yeah. Okay, so then what's next? Constant value types. And var boss employee. Constant value and reference types. Wait, is that it's the same as? Yeah, that's where we're at. Okay, my fault. Value and reference type behave differently when they are constants. To model. Wait, we just did. Where the fuck? Oh, I'm right here. Your new company. I totally fucking missed something. Wait, this is what we did. Then they explained something. Then I explained something. Making the company. Okay, we're at the struct. We don't have the struct yet. Sheesh. Struct company. Struct being a value type, not a reference type. Var boss employee. Your new company struct has one stored property to reflect the employee in charge. Companies change over time, so you made this property immutable with var. Create a new instance of company with Annika as its boss. So what are we doing? It's a new constant called Acme. We're creating an instance of company. And we get this. Oh, the parameter name, yeah. Boss argument is Annika. Okay. And then with Annika, said note that this instance is created with let, so it is a constant. Yeah, sure. Try to change Acme's boss property. Okay. Let Mel equal employee. Acme.boss. Can't do that, brother. Yep. First, you create a new instance of employee named Mel. Second, you assign that new instance to the boss property on Acme. You should see a compiler error on that line. Cannot assign property to, yep. This error is telling you that Acme is immutable. Is an immutable instance, which means you cannot change it. Value types that are declared as constants cannot have their properties changed. Demoting Mel. Poor Mel. All over just a damn programming language example. Lost her job. Darn. Remove the assignment to the boss property to silence the compiler error. And Mel, she's also being... Just kidding, psych, you're not the boss. Mutability works different for reference types. Imagine that. Due to a human resources mix-up, Mel's employee ID must be changed. Try to change the ID property on Mel. And it's not going to let me. Employee, oops, Mel, ID, equal 86. Mel ID. Wait, we're making a new, that's a reference type. So Mel is a instance of employee. So it has a default value. Oh. Mel equal 86. Despite Mel being declared with let, you will see that the compiler is absolutely fine with this ID change. Why can't you change the value of a property on a constant that is an instance of a value type, but you can change the value of a property on a constant that is an instance of a reference type. Yeah. I mean, just yet another reason I don't want to use classes. All of these rules have to apply because of inheritance, has to allow for inheritance. Is the short answer. No. Despite male being declared with let, yeah, okay, why can't you change? Because male is an instance of a reference type, it refers to the instance of employee that was made via this code. Employee. When you change the value of that ID, the value that the ID property stores, you're not actually changing the male variable. Oh, I see. So now Annika's would be 86 too. Let Mel, because we created. Wait, I'm getting confused with the company and. Okay, that's separate, but the Mel thing, employee, separate instance, but it's a reference type. Male ID. Oh, because that's a var. Okay. Because male is an instance of a reference type, it refers to the instance of employee that was made via this code employee. Yep. When you change the value that the ID property stores, you're not actually changing the male variable because it is just a reference to an employee. Because you made ID a mutable stored property, yep, you're free to change however much you like. Yeah, no matter how many times you change male's ID, male still refers to the same instance. I see. So yeah, so literally just same memory location, so the reference to it is constant, but you can change the ID itself because it's a var in the class employee. And that value itself only exists in one spot in memory. Okay, so male's ID still refers to the same instance. Yeah, the thing you cannot do is set the male variable to refer to a different instance of employee, because that would be changing the variable itself. Okay. I wonder if, I don't know this, so I'm going to ask, is in the context of SwiftLang is a synonymous with a pointer. Similar but not entirely synonymous. Okay. Good enough. I'm on Kindle, so using value and reference types together. You may be wondering, can I put a value type inside a reference type? Why would you do this? So a class that would contain a struct and or enum or both? Can I put a reference type inside a value type? The answer to both of these questions is yes, and you did the latter by adding a property of type employee to company. By adding a type. Oh, I see. So on line 21, we sure did. So boss is of type employee, which is a class inside of a struct. Eesh. Boy. However, although we led you to do this without warning, you must be very careful about using a reference type inside a value type. Using a value type inside a reference type does not present any particular problems. So the other way around doesn't present any particular problems using a value type inside a reference type. Yeah, how could you do? Because you can't really control what's cracking in the other way around. Because of inheritance, brother. We just don't want to use it. Stop trying to make it happen. Stop trying to make fetch happen. Suppose that Acme Co is restructured as widget co, and in the process of reviewing employee records, Annika realizes that she is actually employee number 15, not 16. Man, this place has like real issues internally. Fixing Annika's ID. I would have been gone, brother. I'm like, the first time they screwed up my ID, like, I'm not hitching my ride to this this wagon any longer. Very concerned. Acme boss ID. Boss.id. Let widget co equal Acme. And then Annika ID, set that equal to 15 widget co dot boss ID. Command Shift Enter. Oh shit. Command. I can't decide what I. Why doesn't that feel natural? Maybe. Put that back. Tab here. Tab here. And escape. Alright. Right there. Okay, did that work? My string. This is escape now. Nah, I think I want it the other way around. Okay, so escape goes here, here. Perfect. Okay. Where were we? Oh, I need Alt 2. Ah, finally. Oh, that's the same one. Okay. What is this? Alt, Control. What do I don't need that one there. I have delete over here. Maybe that's a better spot. And this can be. I got an extra button. F11. There we go, brother. Okay, so now. Command Shift Enter. Okay, so we went from. So we just print, or not print, but we can just see it. So Acme Boss ID is 16 at this point. Then we have this constant widget co, and we set it equal to Acme, and Acme is equal to company. Which is a struct, so we can look in, and we get the boss. So ID is 16 at this point. Okay. Then we set Annika's ID. So this instance, or no, sorry. This is a class, so it's a reference, so just using the reference to change the instance's ID to 15. Therefore, widget code is now 15. Oh, right. Because widget code, this constant is just, what's immutable about it is the reference to Acme, which is also where it's getting its values from. So if we go look at Acme, it's a constant of type struct, and we made the boss Anika. Wait, boss employee. Yeah, we made it Anika, but oh, okay, yeah. And then we get back to finally to the class where we're able to change the ID because it is the only true instance, or it's the only place in memory where the value actually exists. Everything else, widget co, Acme, anything referring to a reference type, in this case, employee, would fall under that same umbrella, and you can still change the values there. Okay. Yeah, okay. So now what? When you log the value of acme.boss.id, the result sidebar shows 16. You next assign a copy of Acme to a new constant named widgetCo. Remember that company is a value type, so you should expect widgetCo to receive a copy of Acme. Then you update Anika's ID to 15. Last, you check the ID of widgetCo's boss and get a surprise. The boss's ID is now 15, reflecting the change made to Anika's ID. How did this happen? And we just went through that, but I'll go ahead and read it. Remember that the boss property is of type employee. Employee is a class and is therefore a reference type. Even though company is a value type, it can have properties of reference types like employee, and they are still only references. Yeah, this example demonstrates the complications of placing a reference type within a value type. You should expect instances of value types to be copied when they are assigned to a new variable or constant or passed into a function. You should expect instances of value types to be copied, when they are assigned to a new variable or constant, But a value type with a reference type and a property will pass a reference to the same instance to a new variable or constant. Change made to that instance via the property of any one of the constants or variables will be reflected in all of them. To avoid this confusion, you should generally avoid using reference type properties inside value types. Yeah. If you find yourself needing a reference type property in your struct, then it is best to use an immutable instance. Gotcha. P-break. P-break. Surprised it lasted this long. Let's take a shorter one this time. 7 minutes. 7 minutes. Where's my escape button? I think I'll do a quick. Oh yeah, that's what I meant to do. Whatever, it doesn't matter. BRB, meet back. L meet back. Meet back at. What time is it? 13:27 hours CST. There you go. A little military time for you. It's 1:27. Okay. Okay, that actually didn't take nearly as long as I thought it would, so hot dog, brother. And who shot ya? Alright. Hopefully none of y'all are stuck on the toilet. Life moves fast, baby. Can't slow down. Okay, so. God, this thing pulls my fucking hair one more time. Copying. The concept of making copies has been lurking behind nearly every topic covered in this chapter. Indeed. Developers often want to know if copying an instance yields a shallow or deep copy. I have no idea what that means. Swift does not provide any language level support for making a deep copy, which means copies in Swift are shallow. To get a sense of what these concepts mean, let's look at an example. Imagine that WidgetCo hires a new employee. Create a new instance of employees and put all instances into an array. Let Juampa, the hell is that? Employee. Let employees equal Anika, Mel, and Juampa. You create a new employee named Juampa. I feel like I'm mispronouncing that. And add that instance to, and add that instance. What? You create a new employee named Juampa and add that instance. Anika and Mel. That is not reading correctly to me. You create a new employee named Juampa and add that instance, Anika and Mel, to a new array. Okay. The sidebar shows the array with 3 employees, identified by their IDs. Okay. Okay. While adding everyone to the invitation list for a company party, Anika discovers that Juampa's ID was not entered correctly. It's time to shut it down at a certain point, brother. Make a copy of the employees array, update Juampa's ID, and compare employees to its copy. Make a copy of them. Okay. Let party goers equal employees dot last dot ID is equal to 4 last. Oh, like the last. Okay. Oh, neat. So the last character in the employees last. Oh, the last element in the array. So we're setting Juampa's ID to 4. That's what we're saying. If the array is not nil. Employees, party goers. Command Shift Enter. There you go. The last property refers to the last element in an array. It is optional because the array may be empty, so you use optional binding to access Juampa's ID in employees.last ID equal 4. Arrays are structs. Which means that they are value types. So you might expect that partygoers is a distinct copy of employees. So you might expect that partygoers is a distinct copy of employees. Let's see, would I think that? Let employees equal this array, let partygoers equal employees. Yeah, I would think that. Come on, man, don't let this shit bleed out into the... Man, let's just find out what's going on. So you might expect the partygoers is a distinct copy of employees. But employees and its copy, partygoers, have the same contents after you change Wampa's ID property. Why? Why did changing the ID of the last employee in the employees array change the ID of the last employee in partygoers? Oh no. Remember that employees contains instances of employee. Yeah, they ruin everything. The answer is always inheritance. That's why I don't want to fucking use classes. All this stuff goes away. I haven't even wrote any of the app yet. I'm already triggered by it. Remember that employees contains instances of employee. Yeah, so they're pointing out because Jwampa is an instance of employee. And so when we create the array. Oh wait, they're all instance. Yeah, okay. An array of employees. Oh, so it's literally the same thing. Now we're just using it. Now we're using arrays in the example instead of just other constants. But yeah, so let partygoers equal employees, which is an array of instances of employee where employee allows for the ID to be changed. Yep. So it's class inheritance fault again, brother. All right. So then, okay, shallow copies. But what is that though? Tell me what the shallow copy is. Remember that employees contains instances of employee, a reference type. So the partygoers and employees arrays have. So the partygoers and employees arrays have references to the same instances of employee. Jesus. This is very similar to Acme and WidgetCo sharing references to an employee. Putting it all together, last will get the last element in the employees array. Yep, 15, 86, 4. So 4 is the last one. 0, 1, 2, because they're 0 indexed. Yeah. That's a good, I like this little majig. This form, oh, wait. Yeah, putting it all together, last will get the last element in the employees array, which is Jwampa, an instance of employee. When you change the ID, you're changing it for the instance of employee that Jwampa refers to. Thus, the change to Jwampa is reflected in both arrays. This form of copying is referred to as shallow copying. Oh, okay, yeah. So a deep copy would be taking the state that the references refer to, so whatever the values are at that time. Yeah, I mean, how would you do that? Because you'd have to also create a copy based off the value that was in, or no, not there, in employee, because it's an employee. Yeah. That makes sense. I mean, I wouldn't expect it to. Yeah. Deep copy. Yeah, that makes sense. So shallow copy, because it's just copying the references, not the values that they point to. Yeah, that would be silly. Okay. This form of copying is referred to as shallow copying. Shallow copying does not traverse references. A shallow copy of a value type copies the value. A shallow copy of a value type copies the value. Right, but this is not that. A shallow copy of a reference type copies the reference. Yeah. This is what you have come to expect of the assignment operator in Swift. And figure 18.5 is a graphical visualization of it. A deep copy, on the other hand, would duplicate the instance. That's the word, yeah, duplicate. The instance at the destination of a reference. Exactly. I consider myself, brother. That would mean that the indices of the partygoers array would not reference the same instances of employee. Instead, a deep copy of employees would create a new array with references to its own, instances of employee. That form of copying would look something like this. Right. Swift does not supply any means to perform a deep copy, but these are common terms used by developers discussing data modeling needs. So we present the ideas to you here. If you would like this behavior, you will need to make it yourself. Brother, I don't need it. Equality versus identity. Now that you understand the difference between value and reference types, you're ready to learn about equality and identity. God damn. Equality. Oh, yeah. I think I watched a video about this. I do remember this. Equality refers to two instances having the same values for their observable characteristics, such as two instances of the string type that have the same text. Take a look at this sample code. Let x equal 1, let y equal 1. X is equal to y. And that's true. So double equal sign is the equality operator. Okay, yeah. Two constants, x and y, are created. They are both of type int and hold on to the same value, 1. Not surprisingly, the equality check done via double equal sign evaluates to true. This makes sense because x and y hold on to exactly the same value. This is exactly what we want to know from an equality check. Do two instances have the same value? All Swift's basic data types, string, int, float, double, array, set, and dictionary, can be checked for equality. Nice. Identity, on the other hand, refers to whether two references point to the same instance in memory. It's a highlighter for sure. Okay. Let's probably just highlight all the beginning sections of the chapters because they are always useful. Okay, checking for identity. Acme.boss. Acme.boss. So identity is triple equal sign, brother. God dang. It's crazy. Anika. Expected expression after operator. True. Okay. Here the identity check succeeds. Why does it succeed? So acme.boss. Acme.boss. So when we defined Acme, we create an instance of company, which is a struct with a property that is a class, and it's in the variable boss. And so when we created it, we said make the property boss Anika, which Anika is an instance of a class which has a variable here, blah, blah. And so acme.boss would be equal to Anika because they point to the same thing. So where did we define Anika? Yeah, here. So it's the same thing. See how that works there, guy? So company, because because the property. Yeah, okay, that's why. So just to clarify, I should clarify. The struct, or what's important. I was saying Acme. No, wait, I said Acme.boss. No, I said that right. Yeah, okay, my bad. But anyway, yeah, so Acme.boss, not just Acme, but Acme.boss. So just the property. That is, or that evaluates to true because it's pointing to they're pointing to the same place. Anika and acme.boss are both references to the employee class. Here the identity check succeeds not because the boss of Acme has the same properties as Anika, but because the boss of Acme is Anika. Yeah. The boss property of the Acme company is a reference to the same instance that Anika is a reference to. Now try an identity check between new instances of employee. Okay. Let Joe equal employee. Yeah, buddy. Let Sam equal employee. Joe, Sam. So these are new instances of employee. Falso. Right, so acme.boss, where's Acme? Make sure I'm getting that. And we said acme.boss is Anika. Oh, okay, yeah. And then Anika. Oh, okay, so I explained it wrong. It's not that it's pointing to the class, but it's the fact that, yeah, okay, it is Anika. I got you. So here we're saying the boss is Anika, and Anika itself is just a reference. Yeah. So if Anika is a reference and acme.boss is equal to Anika, then it's the same thing. But this is I see. Since these are separate instances, then the identity check would be false. Because we didn't say let Sam dot whatever equal Joe. That's what we would have had to done. Okay, so then now try, wait. Yeah, the identity check fails because Joe and Sam are not references to the same instance, even though they have the same employee ID. What if you want to check for identity on X and Y? What if you want to check for identity on X and Y? You might think you could use the identity operator as an X, Y, but this code will generate an error from the compiler. Why? The identity equality, what do you call it? The identity operator exists to check the memory address of instances referred to by reference type variables. By reference type, okay, that's the key there, brother. Value type variables do not store references, so an identity check would be meaningless. Right. So what if you tried to check for equality on Joe and Sam to see if they had the same properties? Try it. It's gonna be true, brother. Of course it's true. Joe, Sam. Oops. God damn it. Oh, duh. It doesn't even apply either. Can't do it. A compiler error tells you that it does not know how to call the function on the employee class. If you want to check for equality on classes that you make, you have to teach your classes how by implementing the value equality function. You son of a gun. Alright, so doing so entails conforming to a protocol called equatable, which you will read about in chapter 25. We're getting up there because for a while I felt like we'd never get halfway, and now we're over halfway through this MF book. See, I can't keep running. We're going to get all that knowledge. We're going to get it. A compiler error. Wait, we read that. You will return to this example in chapter 25 to do just that. For now, remove the last line. Okay, a little teaser. I'm with it. It is important to realize that two constants or variables can be equal. It is important to realize that two constants or variables can be equal, i.e. they have the same values, yet not be identical. Right, yeah. i.e. they may point to different instances of a given type. Yeah. That'd be an example of there'd be a correlation, but wait, no. You would know the causation, but the correlation would be meaningless. Maybe. But it does not work the other way around. Right. It does not. If two well, yeah, no, that's right. Yeah, because if, yeah, okay. I see it in my head now. Yeah. Yeah, so even though they get created from the same class, if you create two separate instances, they exist. The references are different because they refer to two different things. But they were initialized from the same class, so if you did not change anything about, if you just said it's equal to employee and you don't change the ID in this case, they would have the same values, but they're still different instances. Brother, that's how you do it. All right, so it is important to realize that two constants or variables can be equal, i.e. they have the same values, yet not be identical. Identical in this case, meaning the Swift definition. Because if we saw it as represented by its data shape and we just saw it, it would literally look the same. But they have unique addresses in memory. And more specifically, identity refers to, well, not the, did it say memory address? I don't want to, or do they just stick with the term reference? Equality refers to two instances having the same values. Yeah. Where is it? Identity, on the other hand, refers to whether two references point to the same instance in memory. Yeah, so it is memory address, yeah. Okay, so that makes sense. Hopefully that makes sense, because it makes sense to me. But it does not work the other way around. If two variables or constants point to the same instance in memory, they will be equal as well. It is important to realize that two constants or variables can be equal, like they have the same values. I get that part. Yet not be identical by Swift's definition of it, because they're two separate instances. So that's out, because that's all it checks for. Is it the same memory address? Or that's what the identity keyword or operator looks for, triple equal sign. So, okay, so got that part. Then it says, but it does not work the other way around. If two variables or constants point to the same instance in memory, then they will be equal as well. Oh yeah, okay, I see what they're saying. Okay. If two variables or constants point to the same instance in memory, oh, they mean it doesn't work the other way around between operators. Yeah. Yeah. Yeah, because if you're referring to the same thing or the same place in memory, then it's the same value. So yeah, there would be equality, but not necessarily be a true identity check. Okay, it's sinking. I was just letting it sink. Making sure, okay, what should I use? Structures and classes are well suited for defining many custom types. Structures and classes are well suited for defining many custom types. Before Swift, structs were so distinct from classes in macOS and iOS development that the use cases for both types were obvious. Wait, what? Before Swift, structs were so distinct from classes. Oh, okay. In Swift, however, their functionality added. In Swift, however, the functionality added to structs makes their behavior more similar to that of classes. This similarity makes deciding which to use somewhat more complicated. No, it doesn't. We're not using classes. Still, there are important differences between structs and classes. Yeah, because now that I think about it, anything that I've seen from the class that it could be taken care of, or anything that I've observed from classes in terms of like feature set that I might want to use, could also be supplemented with the type property, because those can be computed. So yeah, no, we're definitely not gonna. But we got through it. So still, there are important differences between structs and classes that give some guidance on which to use when. Strict rules are hard to define because there are many factors to consider, but here are some general guidelines. If you want a type to be passed by reference, use a class. Doing so will ensure that the type is referenced rather than copied when assigned or passed into a function's argument. And yeah, now that I'm saying that, I mean, to be fair, yeah, well, I guess it would kind of just depend, but perhaps, I don't know this for a fact, but I do know for a fact that not making copies of everything is going to be more performant than copying everything. You know, every time you interact with a variable or pass it in somewhere, if you're making a copy every time, maybe that's not so bad initially, but as your app grows, you know. Yes, I'll be interested to see how much that comes into play, because at least for my purposes, because, you know, my application is going to be making network calls to databases, and then, you know, sandboxing. So actually, never mind. I mean, you really, at least for my use case, I'll have to have a copy anyway. I'm gonna want to bring everything down local and create, you know, a little sandbox environment for that session, like on the user's device. At least that's the plan. So yeah, maybe I don't know. There's a lot to find out. What's the other one? Okay, if the type needs to support inheritance, okay, no. Otherwise, you probably want a struct. Yeah. Structs are commonly used when modeling shapes, e.g. rectangles have a width and a height, ranges, a race has a start and an end, and points in a coordinate system, e.g. a point in a two-dimensional space has an x and y value. They're also great for defining data structures. The string, array, and dictionary types are all defined as structs in Swift's standard library. Oh, that's interesting. Dang, okay. I wonder what the most primitive, like what's the lowest level object then? I think it's tuples. We'll ask here in a second. There are some other cases in which you might want to use a class instead of a struct, but they will be somewhat less common than the need for reference semantics or inheritance. You want to use a class instead of a struct, but that would be somewhat less common than the need for reference semantics or inheritance. For example, if you want to take advantage of passing a reference around but do not want a class to be subclassed, you might ask yourself whether you should use a struct to avoid inheritance, or a class to have reference semantics? The answer here is use a final class. Marking a class as final will prevent the class from being subclassed and will offer you the desired reference semantic. Oh! What? Oh, brother. Forget what I said then. You should have said that earlier, brother. I would have not been talking so much shit on classes. Final class. Basically prohibits inheritance, but allows for using reference semantics. Cool. Man, see, there's just solutions everywhere, brother. Tell you what. So final class. Bop, bop, bop. Awesome. I'm pretty sure that's the first mention of it. That would definitely stick out to me. Okay, marking a class as final will prevent that class from being subclass and will offer you the desired reference semantics for instances of the class. In general, we suggest starting out with a struct unless you absolutely know you need the benefits of a reference type. Sure, that sounds good to me. Good advice. Value types are easier to reason about because you do not need to worry about what happens to an instance when you change values on a copy. All I know is if I ever have a team of devs, you know, if it's anything beyond just being an indie dev, then yeah, that linter ain't letting anybody write anything. As soon as you type class, it'll just autocorrect to final class. You won't even know why. For the more curious, copy on write. Oh yeah, what is this? I've heard of this. Ooh, oh my gosh. You might be wondering about the performance implications of Swift's copying behavior. Boy, are we. For example, if you get a new copy of an array every time you pass it into a function or assign it to a new constant or variable, won't you have a wasteful number of copies floating about? What about very large arrays? Exactly, brother. What are we going to do about this problem? The answers depend on your data and how you're using it. Swift standard library types use a strategy called copy on write. Swift standard library type use a strategy called copy on write to ensure that working with value types is not wasteful. Copy on write, or CAL, refers to the implicit sharing of there's that word again, sharing of value types underlying storage. What? Instances of a value type do not immediately have their own copies of data. Really? Oh, you're playing a dangerous game, buddy. They share their underlying storage, with each instance maintaining its own reference to the store. What? Really? If an instance needs to mutate the storage or write to it, then the instance gets its own distinct copy. So that's separate from that. Okay, so that's separate from the lazy eval. That's just totally separate. This is just there. And you don't control that. They share their underlying storage with each instance maintaining its own reference to the store. How is it doing that? Like, so it's holding some. Tell me more about it, brother. Mutate the storage or write to it. So if an instance needs to mutate the storage or write to it, then the instance gets its own distinct copy. I don't like that, brother. I hope you can change that. I mean, or at least, yeah, I hope you can at least control that to some degree, because I mean, if nothing else, I almost immediately just think that feature, like that behavior, will manifest to the app developer as effectively hard to track down reports of like, hey, customers, like, hey, fucker, your app is freezing up. Because at some point in the process, when a particular instance needs to do a copy, and let's say they've been, you know, they're doing a big copy, they're working with a lot of data. If they don't always have the same workflow, the speed of the application is going to be inconsistent, and they might not necessarily be able to communicate to you that, oh, it happens every time I do this or that, because they won't necessarily know what your underlying code is doing each time they, you know, mess with the filter or refresh or change a setting. You know what I mean? So I would rather it just take a long time to start up if that's the case. Like, if you gotta do things, have a, you know, some apps start and it's just like, you just see the splash screen and it just sits there until it's ready to go. Others are nice enough to kind of give you a little progress bar, at least show you that it's working on something. And to my taste, I think that I would much prefer more transparency at the cost of maximum performance, like, you know, doing stuff like this, versus just not even knowing what my software is doing. I'd rather just have not interactive, but, you know, a visualization, just something simple. It could just be a loading bar, but something that tells the user what it's working on. And if they know, they know. It's like, okay, fine. It's going to take, you know, I'm going to use this thing all day. When I come in the morning, I fire it up. It takes 38 seconds to go through its routine, bring in all my localized data, download my settings from the private web server, you know, whatever the fuck. But yeah, I'm not jazzed about that, but and honestly, I'm cheating a little bit, because I say this because yesterday, actually, I think this is almost over, right? We're about to, yeah, I'll show you guys the video. Yeah, but I'm saying this because I just watched this interview. I think I told you about it yesterday, but on Developer Voices, there's a YouTube channel called Developer Voices, and the creator of Swift, Chris Latner, also the creator of Mojo programming language. We're not going to cover that on this show, because it's Python syntax, and I can't believe I used to think that indentation for scope was like the way to go. I was so misguided. But anyway, I'm going to show you that video because he mentions to the host that, because, you know, he's talking about Mojo is very, very new. It's not even, you know, 1.0. It's a superset of Python for working with AI. So a lot of methods for working with the GPU directly, and like parallelizing and all that stuff. You know, they basically needed a new syntax to accommodate all the advancements that we've made on the hardware side, and we needed a higher level syntax to give to the folks working in machine learning, deep learning, AI, you know, Gen, all that stuff. That's what that Mojo language is, just FYI. And it's also just like Swift, it's built on top of LLVM. But yeah, he was there on the interview to talk about that, but he's referring to Swift because this was the last language that he authored. and he's talking about, it kind of offended me a little bit, not gonna lie, but that was just like, you know, the cultist in me, the Swift cultist. Yeah, try not to be that way, but he was saying basically, yeah, you know, Swift had a lot of issues just making all these copies under the hood all over the place. But he said it in passing, like, and he didn't say that, oh yeah, like we addressed that, guys. So I was a little concerned, and this is not an old interview. This is like last week that he did it. You know what I mean? So I'm like, that's the only, like, that wouldn't bother me at all if literally anybody else other than the fucking author of the language had said it. But yeah, that's why it's stuck in my mind. But we'll go fish out the video so you guys can watch it. But yeah, yeah, this allows value types to avoid creating copies of data unnecessarily, but it's not unnecessary if it's in your code, brother. It's going to happen at some point, is my thing. So I just don't like that, because you're not even, I could understand if you said something like, which sounds even more complicated, but you know how the concept of like in your browser, if you've ever seen that setting that says like preloading, like web page preloading, like somehow it can be predictive in nature and load things ahead of time based off X behaviors or whatever. So effectively start to do some work in the background without you having to manually initiate it, to lessen the load when it comes time to actually do the thing. That's the same thing. Streaming is a very similar concept to that. And so, like, you don't need the whole thing. Just give me enough to do the thing now, and then make sure that I have, you know, this by that time to keep on doing the thing. Something like that. But here, if there's no mechanism to choose whether or not you want to do it, or give it some kind of guideline as to, like, if it's this large of an array, just fucking do it immediately when the program fires up versus on read or on write. Yeah, I don't know. I'm just I hate the thought, because I worked in programs like that for the past 10 years. I told you I was working with that ERP program, and, you know, old dusty programs. And that's just easily the worst thing. I went on site on over, you know, I lost count at some point, but it was over like 300 different organizations that I worked with. And, you know, because we would implement the ERP. So I go on site, work with all the different department heads, train them and stuff. And easily, you know, the biggest fucking thing that, like, to me, that it would embarrass me, for one, because I'm there and it's just me and I'm representing the company. So they're fucking glaring at me like I wrote the motherfucker, you know, or like, and it wasn't always the application's fault, but that's just, it comes with the territory. But that's okay. I take that in stride. But whenever you have these like sporadic interrupts in the application, and it's, you know, suddenly it's freezing up and there's no indicator as to what's going on, and you're just kind of waiting for things to load, that's just a confidence killer, you know. That's way worse. And it was the reason I say embarrassing, because a lot of times these companies, like our target demographic was, you know, anywhere from 50 to, I don't know, 2,500 employees. So pretty small businesses, and they were food manufacturers. We had some larger, but like maybe 30% of the base was like mid-tier, but most were growing, and we were their first encounter with an ERP. And so previous to having a proper ERP, like, you know, like a traditional, you buy a server, you install your software there, all your employees work off of your server. So it's just this client server model. So the program gets installed on the server itself, and then we install the client on different workstations, and they just interact with it that way. Well, a lot of times we would get the feedback that, you know, because they're coming from QuickBooks, they're coming from, what was the other one? The small one, fishbowl, whatever, it doesn't matter. But let's just focus on QuickBooks. QuickBooks, a lot of times it was the web program, the web application. So, they don't even have a server. They're just using QuickBooks, and that does all that for them, and they just log into QuickBooks and work. So the fact that our shit was slower, and it's a local network, and it's not millions of customers, it's just them, and for it to be slower, but it's the same amount of data. It's not like they suddenly tripled in size and have all this new data to work. No, we would take the data from QuickBooks, export it, put it into SQL, and then now they're working with the SQL backend, and for it to be slower than a piece of shit, well, QuickBooks is not a piece of shit, sorry. QuickBooks it's for beginners. It really is not meant for enterprise, at least not the entry-level QuickBooks that we're pulling people off of. There is like an enterprise QuickBooks, and that's fine. I have nothing negative to say, but my point is that that's ridiculous, And so this reminds me of that behavior, because that is what was happening. I remember clearly, many times the developers, they were writing it in Fox Pro. Classes everywhere, fucking inheritance. Oh my gosh, that's why I don't want to use it. But yeah, the more and more I learned about it, this is what was happening. And if you can't control it or even explain it well, if you can't even tell the customer at what point in using the program you might set off this kind of behavior, oh brother, that's not good. Yeah, and I don't want to deal with that. So anyway, that was a long rant. So to better understand this idea, you create a very simple implementation of an array to hold instances of type int. Okay, hold on, let me check one. Almost 4 hours today, bro. Wait. Oh, no, 3 hours. Okay, so we'll finish this and then we'll probably wrap here. Oh, yeah. Okay, this implementation will illustrate the concepts at hand, but it will fall short of an actual implementation of Swift's array type. You will see how to create a more complete implementation of a custom collection type in Chapter 21. Chapter are we on now? Figure 18 provides a sketch of how your int array will be implemented to support cow. This kind of figure is called a structure diagram. Okay, what are we looking at? A struct, an array of integers, a buffer, int array buffer, describe, append, insert at, remove at, copy if needed, a class, int array buffer, storage of type, integer, or array of integers. This kind of figure is called a structure diagram, and it uses something called Unified Modeling Language, UML. UML provides a standardized language to describe and visualize a system in software engineering. If the diagram is well formed, you should be able to look at it and write its corresponding code. Many of the conventions are intuitive, but there are a few special symbols. For example, the dash preceding buffer and copy if needed in int array's description means that these members of the struct are private. Oh, that makes sense, yeah. So the buffer is private. In the class, the buffer is private, and then copy if needed is private, meaning you can't just call into those and use them. That's that implicit business again? Gets triggered in accordance with what Swift decides? Is that what you're saying? For example, oh wait, no, we read that. The dash means that these members are private, yeah. Int array will be a struct that has one property named buffer. Int array, one property named buffer, okay. Okay, so properties are in the second section there, and these are methods. Okay. Int array will be a struct that has one property named buffer that is of type int array buffer. Oh, and that's this. So it's private int array buffer stored as. Interesting. Buffer will be a private property as shown here. All these freaking words are running together. Where the hell was enter? So it should be. Okay. Int array will be a struct that has one property named buffer that is of type int array buffer. Buffer will be a private property because you do not want your underlying storage to be visible externally. Right. Int array buffer will be a class with one property named storage that is an array of integers. So that's here. Okay. Your buffer type will be private as well. So here. Because it is merely an implementation detail of int array. So it should not be available externally either. Okay? It may feel strange to use an array of integers as the storage. After all, aren't you doing all this to make an array that can store integers? Well, yes, but a more realistic implementation of an array would use concepts covered later in the book. For now, the main point is that the int array buffer serves as a reference type modeling int array's underlying storage. For now, the main point is that the int array buffer in the class oh wait, it's in two places. Yeah. For now, the main point is that int array buffer serves as a reference type modeling int array's underlying storage. Okay. Yeah, reference. Oh, right. Yeah, okay. So since it's a class, so then int arrays are the reference type modeling int array's underlying storage. Int array will provide 3 public methods central to an array's behavior: append, insert, and remove. Yep. Int array will also have a describe method. Oops. A describe method, so we'll be able to observe changes to the underlying storage. Oh, cool. Huh. Boy, I could have used that. After you set up your initial implementation, you will add the private copy if needed method to int array. After you set up your initial implementation, you will add the copy if needed method to int array. This is where you will implement the cow behavior of your int array type. But int array was, oh, that was the struct. Okay. But why? Well, it's going to tell us, so I guess I don't need to pontificate. So how after you set your time, create a new, this is where you implement. Okay, it's time to implement your array and its underlying buffer. Create a new macOS playground and name it int array. Yeah, okay, brother, relax. Playground. macOS. Next, call it what? What? Int array. Int array. Go and save that, brother. All right, that's cool. Yep. All right. Time to implement. Begin by implementing your buffer class. Okay. All right. So dodo dd. Get rid of that. I for insert mode. Import cocoa. File private. Private. Class int array buffer. Buffer. By body of the class, bust it wide open, var storage array of integers, I say. And we need, it's a class, so we need an initializer, a primary initializer. Duh, everybody knows that. Open up the buddy, and what's in here? Storage. Right, because we need to, purpose of initializers is to make sure that when we initialize an instance that all properties are provided with values. So storage is an empty array. Okay, yep, makes sense to me so far. Then another initializer, brother. This time we expose a parameter called buffer of type int array buffer. Wait, init buffer int array buffer. Oh, can't spell. There we go. Int array buffer. And function body, open that up, bust it wide open, and then storage equals buffer dot storage. So yeah, I don't get what it's doing. Buffer.storage, as in itself, storage is equal to buffer.storage. And buffer would be an int array buffer. I guess that makes sense, but okay, so we only need the second one because we want to be able to expose this buffer parameter. Otherwise we would not necessarily need this. Buffer, okay. Int array buffer is a file private class. This means that the class would need to locate its implementation within the same file as int array. Oh. Int array buffer is a file private class. Oh, so very literal in its meaning. Okay, file private. Okay. That's, I mean, I like that because then you could I mean, mapping it at the file level is nice because then you could, these could be, you know, standalone modules and you wouldn't have to worry necessarily about any of the behavior leaking out. So it can all be self-contained, at least in one file. So the variable storage has the type array of integers and is initialized to be an empty array in the parameterless initializer, which is here. That's what it's talking about here. Line 7. You also supply an initializer that takes an int array buffer instance as an argument. This is only added for convenience as you will use it inside your int array implementation. Yes, brother, that's what I said. That's what I said. Feels good. What a great book. Y'all should just go buy this book. Just patronize these guys. Patronize. Is that the right? I don't know if I'm using that right. Treat in a way that is apparently kind or helpful, but that betrays a feeling of superiority. Treat in a way that is apparently kind or helpful, but betrays a feeling. Oh, well, okay, that's what yeah. Frequent a store, theater, restaurant, or other establishment as a customer. Okay, maybe not. I mean, not really. Just to support these guys. How about that? I'll try to get all fancy with you. Or buy a different book, and then you do your own stream, and then pass it forward. Know what I'm saying? Maybe not the same book, but the variable storage has the type int and is initialized to be an array in the parameter list initializer. Oh, right. Okay, so that's a convenience thing. So now it is time to write your int array type. Create a struct below your int array buffer class. Int array buffer. Oh, yeah. Okay. Now we're getting there. Struct int array private var buffer int array buffer init buffer is equal to int array buffer init buffer is equal to an instance of itself. Okay. Okay. Func describe print buffer storage. Oops, storage. Oh, that's inside the struct. Okay, so that's a method. So we put the method describe on the type int array. Give it its initializer. So it'll require no arguments. So we'll just be able to do something like, whatever. Pass a bunch of stuff into it with no parameter, no parameter name. And we'll also be able to call int array dot describe. Yeah, baby. Okay, so what was that? Int array has a fairly small implementation at this point. It has a private property named buffer on 15 that is of type int array buffer. Yep. This property maintains the backing storage for int array. This property maintains the backing storage for int array. Oh, okay, I see. I was getting it confused with this up here. But it's still odd that, like, this is all within the class, a single class, int array buffer. And within its own scope, inside the struct, the buffer itself is of the type of itself. I guess you can do that. Okay. Yikes. Okay, this property maintains. Okay. You also include a small initializer that takes no arguments and uses the empty initializer on int array buffer. Here. no arguments, and uses the empty initializer on int array buffer. Yeah. Meaning uses this. Oh, so we're saying initialize, set the buffer equal to an empty array. Oh. Set it to an equal array, empty array. Ah, shit. I should probably change these contacts. I wear dailies and I've been wearing these for like a couple months. I just sleep in them too, and it just works. I don't know. Every now and then though, I mean, I'll get like some dirt in it, but incredible, brother. What cost savings? Okay, so buffer, int array, buffer. And no, my eyes are fine, and don't worry about it. Okay, brother. All right, so okay, I was following it and then I lost it, but now let's get back to it because I wanted to have my moments. Okay, so we're in the struct. It provides the backing because it initializes by saying buffer is equal to int array buffer, and int array buffer is, or no, sorry. We initialize and we say buffer is equal to an instance of int array buffer, which gives this private variable buffer its value, and it's of type int array buffer, which is the class itself. And when we initialize the class, we initialize the class, then storage is equal to an empty array, which gives the property in the class called storage its initial value, which is an empty array. Let's see, type of an array of integers. It just happens to be empty. So yeah, that makes sense. And then it makes sense because you would call this method print buffer.storage, and then this would be buffer. Wait, where's storage though? Where's the property? Buffer dot. Oh, I guess you'd end up calling it. Well, no, this is assigned here. Oh, but it would inherit. So I guess you could call describe on either. Is that true? Maybe. But I think I get how it's passing it to it. But that, yeah, okay. It's like an onion. It's like working inside out. Okay, so then now we'll go back to their description. You also include a small initializer that takes no arguments and uses the empty initializer on int array buffer. Yeah, so here, empty initializer, because there's no, we give it no arguments, so we're using this one. Yeah. And then storage, empty array. All right, so then to set up the array storage. Last, you provide a simple describe method to print out the contents of the buffer's storage property. To print out the contents of the buffer's storage property. So, okay, but this is still, it's a value type. Int array. What is int array? Or this is the int array. Maybe it'll make sense if I keep reading. Probably the best thing to do. Lastly, we provide a simple describe method to print out the contents of the buffer's storage property. I guess I'm just struggling a little bit. I didn't think it worked like that, but apparently it does. Meaning, like from the outside, you would be able to access. I guess we learned that you'd be able to access buffer dot. Yeah, you can. It shows it right here. Huh. Okay. Yeah. So just like, yeah, it's blowing my mind right now. I'm not gonna lie. Okay, last we provide a simple describe. I know we read that. This will help you keep track of changes to the array so that you can see how cal works. Your implementation of int array is limited at this point, as is my understanding, brother. All it does is set up a buffer as its backing storage. Yeah, that's all it does. That is important work, but it leaves the array lacking its main features. You need to write some methods to insert, append, and remove data from the array. Actually, you know what? I want to comprehend this well, and I am not. I think we should, I'm just going to start over tomorrow. So, with that being said, I would like to thank everybody for coming on out. You see my handles on screen, and you know the drill. So, please do follow, please do sub, donate, money transfer. All that stuff. And also, if you like games, if you like Halo, if you like competition, or if you just like me, be sure to tune into my other stream every night, 9 p.m. until, you know, who knows? Nah, usually it's like 2 hours max. So like 9 p.m. to, 11 midnight, I'm doing 100 days of ranked Halo Infinite Road to Onyx. Onyx is the top tier there, so, Now, I'm one tier away. I'm at Platinum 6 currently, and I'm on day 50. I think today is day 55. So I'm pretty sure we'll get there, but hey, brother, you never know. But it's a lot of fun, so make sure you check that out. I would like to see you there. If not, guys, please take care of yourself. Take care of each other. Peace, love, and friendship. Okay, bye.